So this is the demo of storage provision using the control plane for DAOS, and we're going to start from where we've just installed RPMs freshly on a system, and the RPMs will have started the systemd service for them, and we're going to just show that we have some certificates installed for authentication with the control plane and DAOS tools. So if you press enter, Mike will just list those certificates. We can see that they're all going to be owned by the DAOS server user. The demo is going to run under DAOS server user, and we can see the correct permissions on the certificates in the default directory for where the DAOS tools will look for the certificates. The control plane is running in discovery mode directly after RPM install, so there's no server config file, so no IO servers will be started, and that enables us to do storage discovery and provisioning prior to restarting the service and then launching the IO servers. So if we press enter, we can look at the journal for the service, for the DAOS server service, and we can see that the DAOS server is listening on the default interface for requests from the DMG tool, from the DAOS client tools. So if we break out of that, we can move on to doing a storage scan. So DMG storage scan using the DAOS DMG management tool. We're going to have a look at the storage available on all the systems, and we can see that we have 8 hosts, and the host list is specified in the config file for the DMG tool, which is called daoscontrol.yaml, and in there we've specified the host list, including those 8 servers, and we can see that when scanning them, we can see they've all got DCPM modules, so persistent memory modules, 12 on each host, and 4 NVMe SSDs on each host as well. So we press enter again, we can see a more verbose output. So this will give us details of the storage devices on each of the hosts, and we can see we've got information about the sockets, about the memory modules, the persistent memory modules, their locations, capacity, and also PCI addresses, model numbers, firmware revision, socket ID, and capacity of the NVMe devices as well. And if we press enter again, we're going to now prepare the persistent memory modules on each of the hosts. So in order for DAOS to use the persistent memory modules, they need to be set into app direct mode, and then a non-volatile DIM namespace placed on top of that that region, the app direct region. The app direct region is set by changing the resource allocation for the persistent memory modules in the BIOS, and then a reboot is required. We are running the second stage of prepare. We've already run the first stage of prepare before the demo, and so we're only running the second stage, which will create the namespace on top of the region, and from there we can then proceed with the rest of the demo. This takes a long time. It takes around, it can take up to 5 minutes. Okay, so the command is returned and now displays the output from the command. So the prepare command processed on all the hosts listed in the host set, and the result was that 6.4 terabyte of namespace was created on each host, and that's 2 namespaces per host. And it shows that a reboot is not required because this is the second time that prepare has been run. As I said, we ran it once outside of the demo. So now we're going to scan showing the PMEM devices. So this will show us the namespaces as opposed to the modules as we saw before. So it can illustrate that the modules have now been converted into usable namespaces, which are exposed as block devices /div/pmem 0 and 1. And those can be then populated into the server config file to be used by DAOS. So press enter again to get a more verbose listing on the storage scan. That will show us again some extra detail, including the capacity, the individual capacity of each of the PMEM namespaces, socket IDs, and also the extra details from the NVMe SSDs. So now we're going to press enter. We're going to discover all the available network interfaces and providers. You can see that it's quite a homogeneous setup. So we have the same NUMA socket bindings and the available providers and interfaces on each host. So if we press enter again, we can populate a server config file with the details that we've arrived at from the provisioning, from the storage discovery and provisioning. So we can see that we are specifying settings for two IO servers. Each of those has a separate per server section in the config file, indicated by the dash at the beginning of the line. And we can see that we have 16 targets on each IO server. The first core of each IO server target will be different. So they are aligned to different processor logical processing units. And we can see that we have the Ethernet 0 used for both servers with a different port. That's for demo purposes. Really, you'd have a separate interface for each of the IO servers to help them perform the best they can. And we can see that in the storage definitions, we're using the /dev/pmem1 namespace that we created earlier, and we're specifying the NVMe as two SSDs, and both those SSDs would be tied to the same NUMA node as the SCM device that we specified, the PMEM device that we specified, and also the targets. The targets would be aligned to cores on that same NUMA node for performance. Okay, and if we press enter, we're going to restart the service. That will restart the DAOS server service on each of the hosts in our host set, and we can press enter again to go back to the journal to see the progress of this restart. And once restarted with the necessary details in the config file, the DAOS server will be ready for formatting of that storage to bring up the IO servers. So we can now see that the storage is now waiting to be formatted on both instances on this host, and we will be prompted to actually do an SCM format. So now if we break out of that, then we're going to use the DMG tool to issue a format command, DMG storage format, and then press enter, and we're going to watch the progress of the storage format. And the storage format command issues this command over the entire host set. So this is happening in parallel across all the hosts in the DAOS system that we're bringing up. We can see that the SCM format is now currently being formatted, and then after that, the NVMe storage will also be formatted, and that will wipe the namespaces on each of the NVMe controllers. So we have clean storage. And we see when that's completed, the IO servers will be then brought up and passed all the relevant parameters. And now we can see from the ranks started on ranks messages that we have two IO servers on this host. This is 118. And the same, we'll have two IO servers brought up and assigned ranks on each of the other hosts specified in the system. And that host list you can see there, Wolf 118 to 121, 130 to 133 specifies 8 hosts, and on each of those hosts, 2 SCM devices and 4 NVMe devices have been successfully formatted. That's the output from the backgrounded DMG storage format command. So now we can break out of this, and we can query the system ranks. So if we press enter, we can see that we have 0 to 15, 16 ranks, and that's two ranks per server, because we've got per host, we've got 8 hosts, and they're all joined to the DAOS system. And if we press enter again, we can see a verbose listing, which gives us more information regarding the UID. So that's the locally assigned UID for a IO server instance on a DAOS server. The mapping to the rank, which is the global identifier in the DAOS system, and the control address where that rank is reachable. The state indicates that they're all joined to the system, and the reason would indicate any other information pertinent to a state change. And if we press enter, we can start an agent. So this is a DAOS agent, which will allow authentication. So we're going to create a pool and container on the system that we now have up and running. If we press enter, that will specify a 1.4 terabyte SCM size and a 1.4 terabyte NVMe size, and we're specifying the pool UID. And then 56 target counts. That's 16 targets on 16 different ranks across 8 hosts, and gives us some size details. And if we press enter again, we can clean everything up, and that's the end of this provisioning demo. So this is the system control part of the demonstration, where we're going to issue some system commands, some DMG system commands to check the state of the system, and then stop the entire membership, stop the DAOS system, and then reformat the storage so that we can clear the storage space and recreate a pool. So we're going to illustrate that. We have the control plane running, and our IO processes have been spawned, and so we can use the systemd command to show the process tree. If you press enter, please, Mike. So we're issuing a status command to look at the status of the DAOS server service running using systemd, and we can see we've got the DAOS server process and 2 child processes, which are the IO servers, and they're running. And then we can see we've got a tail of the journal for the DAOS server system, a DAOS server service. Again, if we press enter, we can show the system query command with verbose that we've got 15 ranks having joined the DAOS system. And if we press enter, we can create a pool across the system. Here we can see we've run the command, and we've got the JSON output from the pool create command output, including the UUID and the number of service replicas, the ranks that are service replicas. And if we press enter again, we can see that when we try and create a pool for the second time, there's no remaining available storage. And so we get a no space error coming back from the pool create command. And if we press enter again, we can see that we have one pool on the system. And it prints the UID and the number of service replicas, or the ranks that are service replicas. So we're going to now perform a controlled shutdown of all ranks in the membership. I'm using the system stop command. So we've stopped all the ranks, and we can press enter. We see the journal from the DAOS server service, and we can see that we've got 2 ranks having exited, and it gives us the information regarding the signal that was used to kill the services, to kill the ranks. And if we break out of that, we can then press enter to see, using the DMG system query command, verbose, we get a nice listing of the 15 ranks, and they're all stopped. And the reason they're stopped is because we've issued a system stop command. So that's fairly well presented there. So if we press enter again, we can have a look at the systemd status of the DAOS server service, and we can see that we've no longer got any child processes in the C group listed there. So both the IO servers have correctly been terminated the ranks, and we can see the journal there. And if we press enter again, we're going to reformat all the system ranks in the membership. And if we press enter, we can see the journal log for the DAOS server service, and we can see that we're proceeding through a reformat. So we've cleared the formatted state, and now we're issuing a reformat, which is reformatting the SCM component of the storage, and then it'll be reformatting the NVMe component of the storage, and this will be happening across all ranks on the system. And we can see afterwards that the ranks will be brought up again in a reformatted state with clear storage, and then we should be able to then create another pool after having reset all the storage state on all of the ranks. So we can see we've got the format summary coming back from the background process. So all the storage on all the hosts in the host set has been reformatted into SCM devices and 4 MDME devices on each host. So if we break out that, we can see that the ranks have now been restarted and have joined the system. So we've got 15 ranks back rejoined in the system. And if we press enter, we can see that we now have no pools in the system. So all the storage has been cleared. And now we're going to create a pool on the empty storage after all have been reformatted. And there we can see we've got the details back from the pool create command. And if we press enter, we can query that created pool. And again, we've got 256 targets as expected. So that's 16 targets on 16 ranks. And we can see the sizes as expected. So that demonstrates the system reformat. We're now going to illustrate some error reporting using the system query commands. So we're going to issue sigkill and sigstop signals to ranks on all of the hosts but one. So on 15 of the hosts. So if we press enter, this script will issue those signals on each of the hosts to the IO server, PIDs, and there we can see we're listing the output on the syslog output from each of the hosts. It's a bit messy, but you can kind of see that on each of the hosts we're getting an error to message to syslog saying that instance 1 has exited, and it gives the DAOS IO server command. Binary name, and then also the reason. So it was issued a signal, a killed signal, and that's why it's exited. So that's just to show that we have the output going to the relevant output for unexpected exits going to the syslog on each of the servers. And if we press enter, we can use a system query command to illustrate that we have lots of stopped ranks and the reasons for their stopping. So we can see that some of the ranks have been stopped through a kill signal, and that shows the reason there. And some of the ranks are issuing a context deadline exceeded because we've actually issued a sig stop. So those ranks have been stopped, paused, and therefore they're not responding to any queries, and therefore their state is then changed to unresponsive. So we can see an unexpected stop with the reason coming up from the ranks that we issued a sig kill to, and we see an unresponsive state with reason context deadline exceeded for the ranks that we issued a sig stop to, and they stopped responding to any signals. So then if we press enter, we'll restart failed ranks, get back to a known state. So we do force stop on all the ranks, and then the system start to restart all the ranks. Now we're back in an operational state, and that then we can then conclude the demo and press enter, and then we can clear up. That's the end of the demo. Thank you.